this demonstrative session for the use of HPC environment under a co-financed project by the European Union with the DYDAS project. DYDAS is the acronym for Dynamic Data Analytics Services. My presentation will show you first some important points about this platform for HPC computation, and then we will move on to show you an example of a practical use of the platform that is present in a beta version. So, DYDAS is a project that involves the creation of a platform capable of handling very large volume of dynamic data. In particular, with the DYDAS project, we promote the sharing and reuse of public data, and so of course private data, in a secure environment with a dedicated framework for accessing, analyzing, processing the data, as well as for showing the results with dedicated and dynamic customizable user interfaces. In particular, we exploit big data technologies, machine learning and artificial intelligence, as well as some advanced services that I will briefly explain you today. Basic data flow management of the DYDAS system. The DYDAS gather up data from very heterogeneous ensemble of possible sources and make it possible to directly upload or to directly connect the data repository online, and by dedicated API which exploits the DYDAS and ATL processes, the data that you can employ in the system will be automatically harmonized and put it on Geospatial data lake, which solve the problem of dealing with so heterogeneous data sources, and which is connected directly with the HPC environment for operating custom modeling through statistical machine learning algorithms such as artificial intelligence, for instance, as well as also for providing the facilities to operate custom algorithms and show the results over a dedicated user interface. A key factor of the HPC infrastructure is the possibility to perform very extensive data analytics in order to extract the information content and to benefit from the knowledge in the different field from various users that can share their data and their models through the platform in order to exploit the HPC processing power for providing readable data and results to the output API of the systems. Of course, there are many different key elements to be considered in order to implement such complex infrastructure, and one of these, one important key element of the DYDAS infrastructure is the so-called Geospatial data architecture, which is an ensemble of procedures aimed to allowing the integration of the different datasets in a seamless, by a seamless approach, regardless of the different sources of data as well as the different data formats and data contents. So this is just a few examples of different types of geospatial data that can be integrated in the DYDAS data lake by exploiting the functionalities of the geospatial data architectures. And this, of course, enable the implementation of, for instance, multi-temporal analysis performed by exploiting the temporal variation of the different type of spatial data, both public and private, from private sources. Another key element of the DYDAS is the presentation platform, which is also called the user experience platform, that is a complete customizable dashboard that can be exploited for presenting the results, for instance, of model runs, as well as for analyzing the information content of the different data sets once they were uploaded in the data lake. We will see some basic functionalities of the dashboard for the presentation today. Of course, this type of project is mainly based on the role of open data for producing valuable information and computing new results by integrating different types of data. In this graphic, you can see the various categories of data that can be handled by means of the geospatial data architecture and the DYDAS data lake. Of course, a very important role is dedicated to the geospatial data in general and to the satellite imaging in particular, that can be integrated by exploiting the data, the geospatial data infrastructure, with other types of information, such as statistical one, historical data, and also IoT data, for instance. The project also demonstrates its potentialities by developing three dedicated use cases, which are here indicated. In particular, we have three main use cases. The first one is dedicated to the monitoring of the mobility by employing IoT sensors. The second use case is dedicated to the energy balancing in terms of offers and demand of energy, and here we will employ a large ensemble of spatial data, including satellite data. The third use case is dedicated to maritime observation, in particular to the forecasting of sea state variables such as waves and currents, and also this use case is related to the energy balancing, since it is possible to forecast also the amount of energy that can be extracted from the waves and current. And of course, in this project, we expecting an important role from the community of users and interested stakeholders. since the platform, as we already said, may provide an easy and seamless access to different kind of data that can be in a certain way mixed and manipulated in order to produce new value and new information by integrated data that in other cases are difficult to deal with since are very heterogeneous, and also because it is required in general huge computational power to produce the expected results. So at this point of my presentation, before to move to the demonstration exercise with the DYDAS platform, I will require your attention over this first data user survey that can be completed by following this link. I can also share the link through the chat if I am able. Also in the last part of the presentation. Anyway, you can see here the link of the platform to the survey platform. Okay, today the sales picture is on this background. Information. At present, we have the possibility to test these two different formats, JTF and XCDF, but in the next future, we will introduce a more extensive ensemble of data formats such as HDF and directly the ISA data formats, NASA data formats, and so on. Okay, so here you have to know what is the data format of the data that you want to upload, and you can also choose an projection. So you have to know what is the projection of the data, and you have to choose also the modality for the inclusion of the dataset in the container. Of course, in this case, we have to insert a new data in the container, which is empty at present. So we can proceed to upload. Here you have a progress bar that show you the progress in the operation, and the pop-up message indicates that you have successfully uploaded the datasets. once all the check was successfully completed, the status passed to the accepted and then to running, and with the running, this running message, the systems is indicated that your model is effectively running by exploiting the HPC feasibility of the DYDAS. Okay, now we can proceed to investigate better the structure of this simple model, also by taking into account the structure of this container, for which we have SRC main folder, under which you can introduce your model that can be composed by a main script, but also by connected functionalities that can be included. Okay, simple by clicking on the main.py, you will see the instruction written on Python language for the different operation that can be produced by the running of this main. Of course, in this simple demonstration, we have maintained the complexity of the model very low by introducing only just a main script. For who are familiar with the Python scripting, you have to import different functions that you want to use, and then here you have the main part, the most important part of the script, which is related to the framework of DYDAS and exploits dedicated functionalities which connects the Python scripting with dedicated resources and facilities of the data lake and the HPC environment. In particular, you have to link the container of the data that we have seen before. Each container is characterized by a link. In the meantime, we have obtained the successful model links, so we have called to download the results for analyzing it. And here you have to introduce the link of the container that you can see directly by interacting with the container folder. These are two important operations which are related to the implementation of the dataset container over the HPC environment. So this part is related to the usage of the HPC in the framework of DYDAS, and must be implemented by using this type of dedicated instructions. Then we have to use this library, which is the transformer libraries, which exploits all the functionalities of the geospatial data architecture and the ATL in order to transform the data to be used over the HPC. For using in a profitable way the HPC, regardless the type of data format, the DYDAS framework implement a transformation in an internal format that can be exploits the HPC computation. Then you can proceed with very standard operation and common operation in Python language. So you can use, for instance, a raster IO to open the data and then proceed with different operations in order to implement your model. We move on directly on the unsupervised classification approach that is here implemented by using an unsupervised simple model, which is the k-means. That is implemented by NumPy-NT array, and then by using scikit-learn to implement the k-means implementation. And the final part of the code is related to the computation of the NDVI and NDWI in order to find what are the labels individuated by the k-means can be classified as agriculture crops or as water in the acquired chain. And the last important part of the code is the opposite of the reading operation, so the movement of the data from the data lake to the HPC, and this.
Sorry, Matteo.
Yeah.
You have 5 minutes.
Yes, we have completed this part, and then we can move directly to show you the final results. I want just to require the attention of our this inverse use of the transformer library in order to extract the data from the data lake and to put the data on the container for the data download. Okay, we can go back. Okay, previously I have already operated the